All right, we've got pre-lab question number 3 here that I would like to illustrate for you. It says, show how you will calculate the potassium permanganate concentration initially and the oxalic acid concentration initially, shown on table 4 for trial 2 using stock concentrations of 0.85 molar potassium permanganate and 0.25 molar oxalic acid. So if you flip your manual over to this table, table 4, trial 2, you'll see that we have 1.0 milliliters of potassium permanganate that is mixed with 4.0 milliliters of oxalic acid, and we mix that with 3 milliliters of water. So 1 plus 4 plus 3 is 8 milliliters total. This is the final volume of your solution. Now if we do potassium permanganate, the volume initially is 1 milliliter. We know that the initial molarity from the stock solution is 0.85 molar. And what we want to do is find M2. We, of course, are using the dilution formula. The dilution formula is M1 V1 equals M2 V2. And so let's go ahead and solve that for M2. It's pretty easy. Okay, and we plug and chug these values in. So we have 0.85 molar, 1.0 milliliter, V2 is 8 milliliters. Okay, and this is going to be, punch it in on your calculator. This is going to be in units of molarity, potassium permanganate. And we use brackets to indicate concentration in moles per liter. And we say that it's the initial concentration because that's hypothetically what the initial concentration is right before anything starts reacting. Okay? Oxalic acid, V1, according to this table, trial 2, I wrote it up here, it's 4 milliliters. Okay, M1 is the stock solution. It's 0.25 molar. And V2, as I mentioned, is 8 milliliters. But M2 is what we're trying to find. What is that molarity when it's all diluted by the other stuff in there? So we solve again for molarity 2. Plug and chug. So 0.25 molar times V1, which is 4 milliliters, divide by 8 milliliters again. It's the same final volume. Milliliters cancels, right? You're left with molarity. And punch that in on your calculator. You probably can do that in your head, but this is molarity of oxalic acid. And again, we use brackets to indicate concentration in moles per liter. And the little I here represents the initial concentration. At the moment, all those solutions are mixed in the mixing tube and right before reaction occurs. So that's the initial concentration. You should show the math for all of these dilution problems. So there are 6 different calculations you need to show for table 5. Okay? You don't have to show how you calculated the average time. You do need to show how you calculate the reaction rate on table 5, and I'll maybe just mention that in another video.